In this section, we're going to be talking about not equality or, equations that we have been working with. Instead, we're going to be talking about linear inequalities. And those are the things that when you see the less than or equal to symbol, greater than equal to symbol, just plain less than, just plain greater than, those symbols are inequality symbols. And so that's what we're going to be working with. Now, when we talked about solving equations, we talked about those two basic rules, and those were the addition property that said you could add anything you wanted to as long as you did it to both sides of the equation. We also talked about the multiplication property, and that one said that you could multiply anything you wanted to as long as you did it to both sides of the equation. Now, those rules are not going to change. It doesn't matter if you're working with equations or inequalities. That whole basic core concept of solving is exactly the same. Your goal is to isolate that variable, get it all by itself. Now, when it comes to working with inequalities, we do have one new rule that we have to introduce, and that is if you multiply or divide by a negative number, you have to flip the inequality symbol over. And that literally means if you have a greater than symbol, then if you multiply or divide by a negative, you have to flip it over and it becomes a less than symbol. So let's work some problems and see what this looks like. We're going to start out with just graphing. Now, before we start with graphing, there are two things that I need to tell you about also, because we have to have some way of kind of identifying a starting point on our graph. And we're going to do that with open circles and closed circles. Now, if you have a closed circle or colored in dot, that means that the endpoint is included as part of the solution. If you have an open circle, that means it's not included as part of the solution. So we're going to use the colored in dots when we see less than or equal to or greater than or equal to, because they also contain equality. So that means that whatever the number is that we're talking about it could be less than or it could be equal to. That means it's included as a point. When we use the open circles is going to be because we see only less than or only greater than as our symbol. So now look at this problem that we have here. We're talking about the x's that are less than or equal to -1. Well, let's just think about what that's talking about. We're talking about the things that are smaller than -1. Okay, we have to have a starting point first, and that starting point has to be here at -1. But we have to decide whether we're going to use a closed circle or an open circle. In this case, because there is equality, we're going to use a closed circle at -1. Now, if you'll remember about the number line, things that go to the left are smaller, to the right are larger. So we would need to color in or shade in everything to the left of -1. Those would be all of the things that would be smaller than or equal to -1. In our next example, we have -5 is greater than x. Usually it's easier to look at these if you have the variable on the left-hand side. So if we were to switch those around, we could do that. And we've actually worked on problems like that before, where we switch them around. The only thing that we need to do here to keep that with the exact same meaning is we do have to flip the symbol over. Because in this case, it said 5 is larger. So -5 still has to be larger than x. Remember, your symbol always points to the smaller number. So if it's pointing to x one way, it has to be pointing to x the other way. Otherwise, you've changed the meaning. Now, we have to have a starting point, and that's going to be at -5. Because it is just a less than, then that means that the -5 is not included, and we would use an open circle. And all of the values that are smaller than -5 would be to the left of that on a number line, so we would shade to the left.